right, good day everyone. Welcome to this channel. uh Today we are going to pick it up from where we'll stop. In our last class we were able to give an introduction to amino acids. We're able to understand the definition of amino acids. We also look at different forms of amino acids, and we look at the L form of amino acids. We look at the ionized form of amino acids as well. And we got to understand that the most stable amino acids or form or structure of amino acids is the ionized structure of amino acids, and also the L form of amino acids are the most stable forms and structures of amino acids. All right, today, as promised, we are going to be looking into the structures of each structures of the 20 amino acids we listed out in our last video. If you haven't watched it, I will advise you to go and check it out because it will help you to understand what we'll be doing today as well. When you watch it, you can come join us as well. All right, let's continue. We made mention of alanine. We made mention of cysteine aspartate, or you call it the aspartic acid. I told you you can call it alternatively aspartic acid, or you call it the aspartate. uh, we have the glutamate. You can call it glutamic acid as well. We have the phenylalanine. We have glycine. We have histidine, isoleucine. We have lysine. We have serine. We have proline. We have tryptophans. We have tyrosines. We have histidines. We have leucine. We have serines. We have valines, and we have so many of them: asparagine, methionine. We have lysine as well. So you can check the list for yourself. We have threonine as well. So these are the 20 amino acids we made mention of in our last class. Today we are going to look at the structures of these amino acids. Students find it very difficult to comprehend or memorize these structures. Of course, looking at them, they are very complicated. Some of them are very similar, as you be wondering how you'll be able to understand the chemistry behind the structures. When you want to draw them, we often mix them up. But today, I'm going to be helping us with a trick that will help us to memorize the structures of this amino acid very, very easily. All right, before that, there is a very good pattern I use. If you We have a specific way or pattern of numbering in Greek. We start our numbering from alpha. We have the beta. We have after the beta we have the gamma. After the gamma we have the delta. After the delta we have the epsilon naught, and so on and so forth. All right, so we are going to be making use of that very pattern as well. Remember from the explanation in the other class, in our last class, we say the second carbon atom here is known as what? The alpha carbon. We say it is the alpha carbon. Are you getting it? It is the alpha carbon. All right. So now, if we move into another carbon, is going to become a beta carbon. If we now move to another carbon, is going to be the alpha gamma carbon. The next one, the delta carbon, and so on and so forth. Okay, so we are going to make use of this trick to easily memorize the structures of amino acid. I'll write it in form of a molecular name that will help you to easily recall the structures. All right, so we have aniline, we have the CH3 attached to the central carbon atom, that is the alpha carbon here. So we can abbreviate the structure of alanine to be alpha methyl. You know, from our organic chemistry, our CH3 is called the methyl. So we can just say alpha methyl. So when we say alpha, it's we have the alpha carbon and we have the CH3 attached to the alpha carbon. So with this abbreviation, you easily recall the structure of alanine. Okay, all right, let's proceed. We have what we called the cysteine. Cysteine, we have this very one to be the alpha carbon. This is the alpha carbon. This is the first carbon. This is the second carbon, and we call it the alpha carbon. And as a matter of fact, is the first carbon atom. We call it the carbon one in terms of this trick I'm showing you now, if you want to use it. So we don't start our numbering from the carboxylic group here. Are you getting it? So this becomes the first one, the second one. Okay, so this first one is called the alpha carbon, and the second one here becomes your beta carbon. So on beta carbon, we have these constituents. Okay, we have this attachment. This is sulfur hydride. Okay, so we can abbreviate the whole of this structure to be beta beta so this is sulfur sulfur is sulfur hydride. Sulfur hydride. I hope you can get it, or better still, you can just shorten it to be beta SH in a more simple sense. Okay, all right. So with this now, you can easily recall the structure of your cysteine. Okay, it's having a sulfur hydride SH attached to the beta carbon. Are you getting it? So that is how to easily recall it. We have another amino acid we call the aspartate. I told you you can also call this aspartic acid. Okay, it is a conjugate of an acid, so we call it aspartate. And you can also call it the aspartic acid as well. The two names, either of the two names are correct. Uh, let's look at the chemistry behind the structures. This very one, we say this is the alpha carbon, right? This becomes the beta carbon. So on the beta carbon, we have the carboxy group. Okay, so it's going to be beta carboxy. Are you getting it? Beta carboxy, beta carboxy. So this is just a short way to remember the structure of aspartate, or you can just say beta COO minus. Okay, so this is just a short way, short trick to recall or remember the structures for the sake of exam, because you find it very, very hard, boring as well, bulky as well uh, to cram the structures of these amino acids. Of course, if you're not careful, you are going to mix them up. But with these little abbreviations, you with this trick rather, you'll be able to record them very, very well. All right, at this point, if you haven't liked the video, uh, I'll plead with you to do so, and also to subscribe. Just give me a like thumb and subscribe to the channel. If you subscribe is not reducing anything from you, it's just to give you notification when we drop another video again. So do it to subscribe as well. Let's continue. All right, the next amino acid is glutamate. You call it glutamate or you can call it glutamic acid. So the two names are correct. Alternatively, you can use anyone. We have the alpha carbon here. We have the beta carbon here. After beta, what do we have next? We have the gamma. Okay, we have the gamma here. All right, so on the gamma carbon, we have this attachment. Okay, so it's just going to be gamma carboxy. Is gamma carboxy or gamma gamma COO minus. I hope you're following. The next one here we have is your phenylalanine. We have phenylalanine. Phenylalanine is an aromatic amino acid. Okay, it is an aromatic amino acid because it's having an aromatic ring attached to one of the carbon atom in the structure. All right, the first carbon here we have the alpha carbon. We also have the beta carbon. It's on the beta carbon that we have this ring. And if you understand your chemistry very well, you agree with me that this ring is a benzene ring. Okay, so we can say abbreviate the structure as beta benzene. Okay, this is beta benzene. I hope you're following. This is beta benzene. I think there's E in benzene. This is beta benzene. This is beta benzene. All right, so or better still, you can just use the structure to represent it. This is beta, and you have something like this, like this, and also like this as well. So this is just the structure of benzene. Okay, so this is beta benzene. On the beta carbon we have the benzene attached to it. We have another one. We have the glycine. We have glycine. We have alpha carbon here. On the alpha carbon we have this attachment attached to it. The reason why we are not considering these very ones, this other attachment, this hydrogen, this one, and this very group as well, is because already we know from the structure of amino acid these ones are constant already. Okay, the only thing that change in the structure of amino acids is the side chain. Are you getting it? Is the side chain that help us to differentiate between the structures of amino acids. Are you getting it? Whenever we move to the next amino acid, something will change in this side chain. Okay, look at what was the side chain. The side chain that was here is supposed to be an R group here. The whole of this place, the whole of this group now came to replace the side chain. I hope you're following me, right? Good. All right, so for your glycine, we have this group attached to the alpha carbon, and we can abbreviate it or shorten the name as alpha hydrogen. Okay, alpha hydrogen. Better still, you can say alpha H. I hope you are following. So this is just the structure of glycine, and as a matter of fact, it is the simplest amino acid. Okay, it is the simplest amino acid. It is the simplest amino acid. I hope you're following. It is the simplest amino acid. You should take note of that. It is an objective question. It might decide to ask you the simplest amino acid. To name the simplest amino acid, it is glycine. Okay, and we say something about this glycine in our last video we said glycine is the property that it has is symmetric. That is to say it is not optically active. Okay, it is not optically active because of its symmetric properties, or in other words you can say it is not optically active because it lacks asymmetric properties. It cannot rotate light. It cannot rotate light. Okay, it cannot rotate light. I hope you're following, right? Hello everyone, welcome to this channel. Today we are going to be looking into biochemistries of amino acids. We are going to be understanding the chemistries of amino acids. By way of introduction, we say amino acids are derivatives of carboxylic acids in which one hydrogen atom of the alkyl group has been replaced by an amino group. Okay, this is what we called an amino group. This is an amino group, or you call it the amine group. It is called the amine group. Alternatively, still correct, this is the amine group. Are you following, please? All right. By way of definition, we can also define amino acids as organic compounds containing the amine, the carboxylic group, and also the side chain. So these are the major three functional groups that can be found in the structure of amino acids. That is to say, the key major elements that are found in amino acids are the carbon, the hydrogen, the oxygen, and the nitrogen. We have carbon, hydrogen, oxygen, and nitrogen as the major element found in the structure of amino acids. All right, above 500 amino acids have been known. That is, we have discovered about 500 amino acids, but it's very important you should take note of the fact that it's just 20 of these 20 of them that are found in genetic code. Out of the 500 amino acids that have been discovered, 20 are only visible in the genetic code. Okay, yes, we just have 20 amino acids that can be found in the genetic code. The remaining ones are less common. They are less common. Some of these less common amino acids, majority of them, as a matter of fact, are the residual modified from the protein after the synthesis of proteins. Sorry, after the synthesis of proteins, most of the products we got are these less common amino acids, apart from the 20 amino acids that are visible in the genetic code. All right, very quickly we are going to be looking into the structure of amino acids. We are going to be understanding the chemistry behind the structure of amino acids. I'm going to give you the most stable structure of amino acids. We have this here, and we have the amino group here, and then the side chain here. All right, so this is the structure of amino acids, and this is the ionized structure of amino acids. This is the ionized structure of amino acids. We have the unionized structure as well. The unionized structure of amino acid is going to be in this way. We have this. We have this. Sorry, there shouldn't be a positive here, and we have the side chain here. So this is the ionized, unionized rather. This is the unionized structure of amino acid. Okay, out of these two structure of amino acid, that is the ionized form and the unionized form, the ionized structure of amino acid is more preferable. That is to say, this one is more stable. It's most preferable because it is more stable. Okay, this one is not very stable. So most of the amino acids found in our body are in an ionized form. You should take note of that. All right. The first carbon atom here is the first carbon part of this structure is what we call the carboxylic group. It is known as the carboxylic group. The first carbon atom is known as the carboxylic group. The second carbon atom is called the alpha carbon. The alpha carbon. It is called the alpha carbon. Let me write it in words. Alpha carbon. All right. What do I say so far? I say the first carbon atom is the carboxylic group. This is the carboxylic part, and the second carbon atom is known as the alpha carbon. Okay, it's known as the alpha carbon. The alpha carbon, that is the second carbon atom of amino acids, or most of the amino acids are joined together by a covalent bond to 4 different groups. You can look at the constituents, the group attached to this very carbon atom here. We have the hydrogen as a group, we have this amino group, we have the side chain, and we also have the carboxylic group as well. So in most of the amino acids, we have 4 different constituents attached to this alpha carbon atom covalently. They are joined to this very carbon atom covalently, and that establish the what we call the asymmetric properties of amino acids. The asymmetric properties of amino acids. Okay, most of the amino acids are asymmetric in nature except for glycine. So the asymmetric properties is not visible in glycine because of the structure of glycine. We have a similar constituent attached to the alpha carbon. So in glycine we have what we call the symmetric properties. So asymmetry is not possible in the structure of glycine. Okay, all right, I'm going to take that again. You should take note of this, that all amino acids are asymmetric except glycine. All amino acids, I will abbreviate it AA, they are asymmetric. Except for glycine, which is symmetric. Except for glycine, which is symmetric. So you should take note of this. All amino acids are symmetric except for glycine, which is symmetric. You should take note of that. Very, very important. All right. Because of this asymmetry properties of amino acids, they can exist in 2 optical form. Are you following, please? Because of these very properties, they can exist in 2 optical form. That is, we have the L form, we have the L form, we also have the D form of amino acids. Are you getting it? The L form have the amino group to the left hand side, just as the letter implies. The L stand for left hand. Uh, this very group is attached to the alpha carbon at the left hand side, while the D form have the amino groups attached to the alpha carbon from or at the right hand side. You can see it here in the structure. This is it. All right. We also take note of the fact that most of the amino acids found in our body are in L form. Okay, these are in L form. Most of them are in L form because the L form of it is more stable. The D form of it is not very stable. That is why it's advisable we anytime we are drawing the structure of amino acids, it's advisable we make use of these structures. Okay. All right. Very quickly, I'm going to run over the 20 amino acids that are visible in the genetic code. Those ones that can be found in the genetic code, and then we look at their structures as well. We are going to look into them. I'll run over them. I'll tell you 1 letter abbreviations for each of them and the 3 letters abbreviation for them as well. All right. We have alanine. We have 1 letter abbreviation for alanine. We have A, and we have the 3 letter abbreviations for alanine. We have the ALA, that is ALA. These are the first 3 letters that we can find. So we write them out. We have 16. We have C. We have 3 letter abbreviation to be CYX. We have aspartic acid. Some people call it aspartate. Alternatively, the two names are still correct. So we have 1 letter abbreviation to be D. If you observe something, you will see that the letters of alphabet, that is the first letters, this very one does not obeys the order of alphabet. We have A to start the name, and we are having D to be the first letter of abbreviation, while other amino acids are having A. Why they respect the first letters are yes. This very one does not obey the order of alphabet. All right, so we have 3 letters abbreviation for it. We have the ASP. We have the ASP is that is for aspartic acid. We also have the glutamic. We have the glutamic acid. We have glutamic acid. We have glutamic acid. First letter abbreviation, 1 letter abbreviation. Sorry, we have the E, and we have a 3 letter abbreviation to be glue here. We also have an amino acid called phenylalanine. Phenylalanine, we have F as 1 letter abbreviation, and we have a PHE as 3 letters abbreviations for it. We have glycine. We have G as 1 letter abbreviation for glycine, and we have GLY as 3 letter abbreviation for glycine. We have another amino acid called the histidine. We have H as the 1 letter abbreviation for it, and we have what we call HIX as 3 letter abbreviation for histidine. Of course, if you look at it, these are the first 3 letters we can find. That is HIX. We have isoleucine. First letter abbreviation, 1 letter abbreviation for it is I, and 3 letters abbreviation for it is the ILE. Okay, of course, if we have isoleucine, is an isomer of an amino acid, and that amino acid is called the leucine. Okay, so the isomer of leucine is called isoleucine. So leucine, 1 liter abbreviation for leucine is L, and 3 liters abbreviation for leucine is LEU. We have lysine. 1 liter abbreviation, we have K for it, and we have for your 3 liters abbreviation for LYX, and we have an amino acid called the methionine. We have 1 liter abbreviation for methionine to be M, and we have 3 liters abbreviation to be met. That is MET. That is the first letter. You can fetch it out for yourself. You see them for yourself. All right. We have an amino acid called the asparagine. 1 liter abbreviation, we have the N, and 3 liters abbreviation, we have the ASN. Of course, it's starting, we have P here, but already, if you remember, we have used P, we have used ASP for our aspartic acid. So if we should make use of ASP again, it's going to be a tautology, and it will be very difficult to differentiate between the two amino acids. So we put N here to differentiate between the abbreviation for your aspartic acid and your asparagine. Okay, another amino acids that we have is what we call the proline. Okay, we have the proline.